Okay, today we're going to learn how to do electron configuration. And so you will need your periodic table that we have color coded. I'm going to switch my camera to where you can see what I am looking at as well. And so I do have a copy of the periodic table here with us. So when we go through and we're looking at the periodic table, everything should already be color coded on yours. But just to recap, the S block is everything that's in yellow on my periodic table. So we have column 1 here, column 2, and then if you notice over here on the side, we also do have helium, which belongs into the S block. We get into the P block. The P block is green, and it is a complete square. It does not include helium, but it's everything in columns 13 through 18 except for helium. On my periodic table, our D block is all in blue, and if you notice, element number 57 and element number 89 actually do also belong into that D block. And then everything else goes into the F block. Now, here's what's interesting about electron configuration. We're going to go through and we're going to number the period, and we're going to say what the block is, and then we're going to count how many that there are in that block. So if we were to start out with hydrogen, and I've got a note card here, and I'm just going to go ahead and write it on the note card so you can follow along. Let's say I wanted to know the electron configuration of hydrogen. All I would say is 1, because it's in first period. Then I would say S because it's in the S block. And if I count how many there are, there's only 1. And so we're going to write that as a superscript. So that would be the electron configuration of hydrogen, I'm sorry. And so the whole purpose of doing what we're doing is to go through and to make sure that we can kind of describe where those electrons are. In physical science, we're not going to go super in depth with this. When we do get into chemistry, one of the things that we look at is the molecular shape of how those atoms can bond with each other. And so it's really important to know where those electrons are. So if we were going to look at helium, helium is He. And I don't know if you've noticed so far on the periodic table, but if you've looked at it, we always capitalize the first letter. And if there's more than one letter, some of our elements only have one letter, but if we have a second letter, then we don't capitalize it. So this actually looks like the word He, and that stands for helium. So we're going to start at the very beginning. And we're going to say, okay, it doesn't matter where it falls in the periodic table. We have to start at the very beginning. So we're going to say we're in first period. We are in the S block, and we're going to see how many we have. So this will be 1, 2. So helium would actually be 1s2. Now, let's say we wanted to go on down into the periodic table. Let's find carbon. And if you look, carbon is over here in the P block. It's in second period. It is a big C, and the atomic number is 6, which actually means it has 6 electrons. And as I go through and I show this, one of the things you can do is you can count all these little teeny tiny numbers up here. They're called superscripts. And you can count those, and they'll tell you, after you count them and add them all together, tell me how many electrons are in that element. So for hydrogen, we should just have 1 electron. For helium, there should be 2 electrons. Let's do carbon. So it doesn't matter where the element is found. We always have to start at the beginning. One of the things I always like to tell my students is, it's like school. You know how you have to go to first period, and then you have to go to second period, and then you have to go to third period. We have to do that before we can see our best friend sometimes. And so for carbon, we're going to start out with first period. We're going to say 1 for the first period, and that's the number over here on the side. Then we're going to say S because it is in the S block. And then we're going to count how many S blocks there are. 1, 2. And what you're going to start to notice is all of your blocks have the same pattern. In the S block, you can only have 2. In the P block, you can only have 6. The D block, you can only have 10. And in the F block, you can only have 14 elements. And so it's kind of interesting to see that. So we got through with first period. Our friend's not there. We're looking for carbon. Carbon's actually in second period. So we're going to go down to the next row. And so if you notice, we start with 2. Well, these first 2 elements right here are both in the S block because on my periodic table, they are in yellow. So we're going to say 2S, and we're going to count how many there are. And in this S block, we still have 1, 2. Now, if we were doing lithium, for let's say, we would just say 1s1. But we're not doing lithium. We're going to go on over here to carbon. So we're going to say 2s2. Now, this is where it gets a little bit tricky because if you notice, we've now come to a different block, but we're still in second period. So if you ran your finger straight across, you're going to see we are still in second period. So this is still going to be 2, but now we're in a different block. We're not in the S block anymore. If you look at my periodic table, the green represents the P block. So we're going to say 2P. Now, let's count how many P blocks we see here. So that would be 1, 2. And so we're going to say 2P6. Now, here's what's interesting about that. I said earlier, if we count all of our little teeny tiny numbers, up here at the top, it's going to tell us how many electrons we should have total. And so that is 2, 4, 6. If you look at the atomic number of carbon, that's the number at the very top of that, that's also a 6. And that's going to tell you how many electrons carbon should have. All right, so we're going to do one more together. And then I have an assignment for you to do. And in that assignment, what I want you to do is I'm going to give you an element, and I'm going to give it to you as an abbreviation. And I want you to go through and I want you to figure out what the electron configuration is. So the next one we're going to do is actually going to be sulfur. And if you notice, sulfur is a big S. Sulfur is in the third period, and it's in the P block. So let's go through the process one more time. We're going to start with first period. You got to go to first period before you can see your friend in third period. So yeah, first period. First period is in yellow, so that means it's the S block. And we have to count how many there are. 1, 2. Once we get done with the first period, then we can go to second period. And if you notice, second period also starts with the S block. Every single time we start over with a new period, it's always going to start with S. And we're going to count how many we have. 1, 2. We're going to write that down. We're going to go straight across. Now we are still in second period, so we have to write that again. But this time we're in the green, which on my periodic table means the P block. So I'm going to write P, and I'm going to count them. 1, 2, 3, 4, 5, 6. So we do have 6 elements in the P block. All right, so let's go to the next row. In the next row, in third period, we actually are in third period, and we're going to be in the S block because it is yellow. And like I said, color coding things makes it so much easier for us to see that. And we're going to count how many we have in the S block. 1, 2. So we do have 2. All right, but we are not finished because if you go straight across, you notice we also have a P block over here. So we're going to rewrite 3. And this block is the green block, and on my periodic table, that means it is the P block. I'm going to write a P, and I'm only going to go to sulfur. That's all we wanted was sulfur. So I'm going to count 1, 2, 3, 4. And you do count the one that you actually end up landing on. So if I go through and I count this up, if you notice that there is a 16 on the sulfur. So if I add all these little teeny tiny numbers up, I should get 16. We know 6 and 4 is 10. 11, 12, 13, 14, 15, 16. So that is correct. So that's one way to double check yourself to see if you get it right. So on the worksheet today, I just want you to go through and I want you to write out what we call the electron configuration, which is what this is, and then either snap a picture or upload it, scan it, send it back into me, and I'll check that for you.